Welcome to another lecture in the Novice Anaesthesia programme. Today's talk is going to cover demonstrating the functions of the anaesthetic machine. The learning objectives for today's lecture are becoming familiar with the different components and functions of the anaesthetic machine, learning how to check each of these components so that it is safe to use so you can deliver an anaesthetic, and also understanding when these checks need to be done, if they need to be done at the beginning of the list, or if they also need to be checked again before you start each anaesthetic case. The curriculum content covered today is the code IAC D01, demonstrating the functions of the anaesthetic machine. In addition to covering this domain, you may be able to map an assessment on this with other curricula, for example, those I've listed here. This just shows you how you would be able to map these different curriculum competencies on the lifelong learning platform. So why do we check the anaesthetic machine? It is our responsibility to understand how the anaesthetic machine functions and check it before its use. We should only be using equipment that we feel confident to use and that we've been trained to use, and it's an essential part of ensuring the patient is safe when we deliver an anaesthetic, as by checking the machine beforehand, we can avoid errors that occur from faults within the machine, which could have detrimental effects for patients. In 2012, AAGBI set out a safety guideline which outlines the checks that should be completed with regard to the anaesthetic machine and other anaesthetic equipment that we use. This slide just shows you that checklist. We will now be discussing each element of the checklist in turn and how you check each component. Before beginning to check the anaesthetic machine, you need to ensure that a self-inflating bag is available. A self-inflating bag should be available usually on the back of the anaesthetic machine and should be available anywhere that you deliver an anaesthetic. This is essential as it is an emergency piece of equipment that can be used if the anaesthetic machine fails. Before beginning to manually check the anaesthetic machine, new modern anaesthetic machines often now have automatic checks that they can complete. They will self-test essentially when you switch them on and select this. This, however, does not replace the traditional manual machine check that we will talk about today. However, any tests that are completed by the machine don't necessarily need to be rechecked, as it's assumed that this is correct. The first stage in manually checking the anaesthetic machine is checking the power supply. So you should check the workstation is connected to the mains power supply and that this is switched on. You should also be aware of any backup power supplies that are available, for example, generators, and backup batteries should be adequately charged so that they can be ready to use if required. The second stage of checking the machine is checking the medical gas supply. Medical gases are delivered to the anaesthetic machine via two means, primarily via pipelines, and in the case of backup supply via cylinders. These medical gases are colour-coded. In the UK, oxygen is white, for example, nitrous oxide is blue. The pipeline gases have a pipeline pressure of 4 bar or 400 kilopascals. They are connected into the wall via what is known as a Schrader valve. The Schrader valve is also colour-coded. They are connected to the anaesthetic machine via a non-insulated screw thread connector. When checking the machine, you should check that the colours match up at the Schrader valve and the pipeline, and that you should also perform the tug test, ensuring that when you tug the pipeline, it is securely seated in the Schrader valve at the wall. In addition to the pipeline, you should also check there is an adequate reserve supply of oxygen and other gases that are available via cylinders on the back of the anaesthetic machine. These cylinders should be full, they should be securely seated, and they should also be turned off so they are not leaking. Next, we should check the flow meters. The flow meters indicate gas flow rates of the medical gases that we are using. Pictured here are oxygen, nitrous oxide and air. You should check each of the dials individually and ensure that they move freely, and that the bobbin inside the flow meter moves freely and also doesn't stick. At this point, you should also check the hypoxia guard. This is where you turn on nitrous oxide, and by visualizing the flow meter, you can see that at least 25% oxygen will also flow to prevent a hypoxic mixture being delivered to the patient. If you then subsequently turn the oxygen flow off, we should see that the nitrous oxide flow will also stop. We should also turn the oxygen flow to maximum and check that the oxygen analyzer displays that it is approaching 100%, ensuring that this is correctly working also. So next we need to check the oxygen flush and also that the suction is working. The oxygen flush is pictured here. The oxygen flush essentially is a bypass control so that it will deliver oxygen at the pipeline pressure, so at 4 bar or 400 kilopascals. So you should test the oxygen bypass control, and there shouldn't be a significant decrease in pressure, and that when you stop pushing the oxygen flush, that the gas flow ceases. Secondly, you need to check the suction, so you should check that you have the correct suction equipment, whether that be a Yanker sucker or a suction catheter, and you should ensure all the connections are secure, and that when the suction is turned on, it is able to generate the adequate negative pressure we need for it to function correctly. So the next stage is to check the whole of the breathing system. So while checking the integrity of the breathing system, you need to check that there are no obstructions, no leaks in the system, and that all the connections to the anaesthetic machine are secure. They are attached via a push and twist motion, and there shouldn't be any foreign material or foreign debris within the breathing system. You should then complete a pressure leak test. This involves occluding the patient end of the breathing system, pressurizing the system to between 20 to 60 centimeters of water, which you can do by means of the oxygen flush, and then compressing the reservoir bag. Because you're occluding the patient end, there should not be any significant decrease in pressure. If there was a leak in the breathing system, then you'd see a significant decrease in pressure when doing this test. Finally, you also need to do the 2-bag test. The 2-bag test is a test that you should do after you've checked the breathing system, the vaporizers, and the ventilator. So I shall talk about this a little bit later once we've discussed the other elements. So next we need to check the vaporizers. The vaporizers convert the liquid anaesthetic into a vapor so that it can then be delivered to the patient. These vaporizers are colour-coded according to which volatile anaesthetic is present. We should ensure that they are correctly seated and their locking mechanism is engaged so that only one vaporizer can be turned on in turn. If you turn on one vaporizer, then the other vaporizer should lock so that it cannot be turned on. We should also check at this point that the control knob can be rotated fully so that it can be fully turned on if required. And we should also check the filling of the vaporizer, so checking that it's adequately filled, not overfilled, and that the filling port is also closed. We should also check that the vaporizer is not tilted. Any tilting of the vaporizer could lead to a dangerously high concentration of anaesthetic being delivered to the patient. You should also then complete the manual leak test. So this involves setting the oxygen flow to 5 litres a minute, occluding the common gas outlet, and assessing to see if there is any leak from any part of the vaporizer. If a leak is present, then the flow bobbins would dip with regard to the vaporizer. Finally, before moving on, you need to check that the vaporizers are turned off. So the final stage of checking the breathing circuit is taking a look at the ventilator. So you should ensure that you configured it for the use that you want it to, depending on what mode you intend to use. You should set the controls for use and ensure that you can generate an adequate pressure during the inspiratory phase of the cycle, and check that the alarms are both working and configured for what you would like to achieve. You should also check the adjustable pressure limiting valve, or the APL valve. Check that it is set to however many centimetres of water you want it to, or set to minimum. And check that the switch indicating if you're using the ventilator or the reservoir bag is correctly set. So the final stage in checking the breathing system, which should be done after checking the vaporizers, the breathing circuit, and the ventilator, is the 2-bag test. This involves attaching a test lung to the patient end, which essentially simulates a patient's lungs. After doing this, you manually ventilate with fresh gas flow of 5 litres a minute via the reservoir bag, and check the patency of the whole breathing system. You then subsequently squeeze both bags, the test lung and the reservoir bag, to assess if the APL valve is functioning correctly, and that once it reaches a certain pressure that you've selected on the APL valve, gas is able to escape. Following this, you then switch to the ventilator, turn the fresh gas flow to minimum, turn the vaporizers on in turn, and check there is no loss of volume within the breathing system. Ideally, when a breathing system is not being used, you should protect the breathing system with the test lung, which prevents entry of foreign bodies into the breathing system. So with respect to checking the breathing system, we've discussed the checks that we would do if a circle system was attached to the anaesthetic machine. However, there will be occasions where we are using alternative breathing systems. Pictured here is a Bain circuit, which is a different type of breathing system. The Bain circuit has additional specific checks that should be completed if this is being used. This is out of the scope of today's lecture, but is it important to learn how to do these checks if you use the Bain circuit in your hospital, and also for the purpose of the Royal College exams. Secondly, pictured here is the auxiliary common gas outlet, which you can see below the oxygen flush in the picture. This is the site where alternative breathing systems may be attached. For example, in paediatric cases, a T-piece breathing system may be attached to the auxiliary common gas outlet. It is therefore particularly prudent to check that the auxiliary common gas outlet is selected if you're using an alternative breathing system, and that once it is no longer in use and you are using the circle system again, that the dial is set to the circle system. Next in the checklist is checking the soda lime. The soda lime is responsible for absorbing waste carbon dioxide that is produced by the patient. It is seated in the inferior part of the anaesthetic machine and should be correctly sited, and there should be an adequate supply. The soda lime changes colour as more carbon dioxide is absorbed, which is based on the pH change of the granules within the soda lime. Different indicators are used. A common indicator, for example, is ethyl violet, where the soda lime changes from a white or colourless granules to purple granules when the soda lime is exhausted. Different indicators exist. It's important to check what indicator is used in your hospital and be aware of what colour the soda lime will be if the soda lime is exhausted and needs to be replaced before use. Scavenging. So scavenging is the removal of waste anaesthetic gases. It's important to ensure that this is correctly working, as there are safe limits that have been set out by the Control of Substances Hazardous to Health according to how much exposure there should be to anaesthetic gases. The scavenging is often a clear tubing which is attached into the wall. It should be switched on and functioning and connected correctly to the appropriate exhaust port of the breathing system and the ventilator. So in addition to checking the whole of the anaesthetic machine and its connections, it's also important to check that our patient monitors are working correctly. The AAGBI set out standards of monitoring, so there are separate guidelines for this that are the AAGBI's standards of monitoring during anaesthesia and recovery guidelines, which I have put a link to at the end of this lecture, which discusses which monitors are essential during the induction and maintenance and recovery of anaesthesia. You should check that all the monitors are configured correctly within the limits of what you would like, and that there are no obstructions, kinking, or leaks to any gas sampling lines. Alarms should be set before using the anaesthetic machine, and also you can change the cycling times, frequency of recording of non-invasive blood pressure, and also set limits to what the adequate saturations are, heart rate, and blood pressure. You should also additionally check all your airway equipment. So you should check you have appropriately sized airway equipment and that the equipment that you're using is patent, it's clean, there are no obstructions, leaks or damage. You should also check that you have bacterial filters. So bacterial filters are single use, and that the catheter mount is clean and ready to use. Angle pieces on catheter mounts are single use as well. You should check that there is a range of endotracheal tubes, laryngeal mask airways, and also check that you have appropriate laryngoscopes available. Finally, you should also check where your difficult airway equipment is. Check that it's readily available, it hasn't been moved, and that this equipment has also been checked in case it needs to be used. So the final step in the anaesthetic machine check is to double check a few different things. So you need to check that you have resuscitation equipment available. So you want to know where your resus trolley is. You need to double check again that you have difficult airway equipment available. If you are using total intravenous anaesthesia, which is an alternative means of delivering anaesthesia via IV anaesthetic agents for maintenance as opposed to volatile anaesthetic agents, you should be familiar with the pumps that you're using, and you should check these pumps before use. You should again double check that there is a self-inflating valve available for an emergency, and again double check that the configuration of the common gas outlet is correct, whether the common gas outlet is selected or the circle system is selected. So this again just shows you the checklist for checking anaesthetic equipment that we've now discussed in turn. So all of these checks should be completed before an operating list begins. In addition, before each anaesthetic case, we should be checking the whole of the breathing system, the ventilator, the airway equipment that we have that is available and spares, which is particularly prudent if we're doing paediatric cases or suspected difficult airways. And you should also check that you have clean and working suction. So to conclude, we have gone through each step of checking the anaesthetic machine in turn, and I hope I've explained to you some of the functions of each of the components of the anaesthetic machine. You should continue to practice checking the anaesthetic machine so you become comfortable with it, and it's also important to document that you've done these checks in the notes, as ultimately it is your responsibility to ensure that the machine that you're using is safe to deliver an anaesthetic. So thank you for listening. I hope you enjoyed this lecture. If you wouldn't mind completing our short survey monkey to help us improve the content that we've made available, we'd really appreciate it. The link is below the video. Finally, there are a few references here and some further reading points with some links to some guidelines on monitoring and checking specific breathing systems such as the Bain circuit.